K3U. This is the first new lesson in this unit, and although it's a new lesson, some of the concepts are things that you've seen before. Okay, so our goal today is I can if determine if a relation is a function and state its domain and range. So first of all, we'll make the correction to Mrs. Broadhagen's stuff. There we go. Okay, so let's take a look at this. So section 1.1 from your textbook. So the first thing when we're talking about this is domain. What is that? So first of all, the domain is a set of all possible input values, which usually are x's, which allows the formula to work. So possible that allows the formula to work. So that means if somewhere in the equation it has x in the denominator, for instance, obviously what will not work is if x is 0, because if we have 1 divided by 0, that doesn't work. That is mathematically impossible. So 0 would not be one of the possible input values. We'll talk a little bit more about that somewhere else along the line in this course. Now the range is a set of all possible output values, usually the y, which result from using the function formula. So first of all, we're going to talk about notation when we're talking about domain and range. Now you've seen this before. We have what curly brackets, parentheses, at holding our domain or our range, depending on what we're doing. Now this is how it's actually read. However, we start with x. X is, and this could be an element of or in the set of. So x is an element of real numbers and the straight up and down line such that. Okay, so math is its own language in a sense. So x is an element of real numbers such that, and then it tells us how that works. So x in this case has to be greater than or equal to 12. Okay, so sometimes you'll see x is in the set of real numbers such that. Both of them are interchangeable, okay, depending on whether you're talking about elements or set notation. So first example is pretty easy in a sense. So it says state the domain and range of the following. And if we look at the first one, they've given it to us as a set of ordered pairs. So the first thing we're going to do is we're going to look at the domain. Now remember, domain is the first, okay, first set of possible, so it's usually the x, and you can see that it is the x. So for us, the domain is going to be the 1, the 3, and the 7. So what we need to do first of all is write down d for domain equals x. It's in the set of real numbers. Everything we're dealing with is real numbers, such that x equals 1, 3, 7, and then I close it with the curly brackets. Okay, the same is true for the range. We take the y value, so it's going to be 3. Notice there are two 2's. I do not have to put them twice. I only have to put one of them. So range, y is in the set of real numbers such that y equals 3 or 2. It's that simple. Now sometimes we're given a graph and we're asked to find the domain and range of it. So let's take a look at this first of all. So remember, domain is the x value. So if I take and highlight just the x-axis, so this is the x-axis. Now you can see there's some places where we're never going to have values for x. And those values here are in the negative part. So we can't have it in the negative part. So what we're going to do is, you can see when I highlight this time that x, the values start here at 0 and they appear to be all greater than 0. So that is what my domain is going to be in this example. So I have the domain, x is in the set of real numbers such that x has to be greater than or equal to 0. Now the range, again, we're looking at it as being along the y-axis. So we're looking at values here. Well, it appears that this graph is going positive, and it doesn't appear that anything's going to stop it. And the same thing when it comes to the negative values along the y. It appears that this sideways parabola is going to keep on going and nothing stopping it. So in this case, our range is also the set of real numbers. And unlike the domain where there was some kind of restriction, y can be any real number, positive or negative. So that is how we do the domain and range for given a graph. Now I'm just going to put up the blind so we can talk about this and highlight things that are important. So now a function is a special relationship between values where each of its input values, so each x, gives back exactly one output value. Okay, exactly one. So first of all, if I'm given a set of ordered pairs like we were in one of those examples, it means that for each x value, there is only one y. So each x has only one y value. It can't have two, only one. Now, if I'm given a graph, it's actually even easier in a sense. If I take a vertical line and pass it over the graph, if it only cuts the graph in only one place, it's a function. And we call this the vertical line test. And you have seen that before, vertical line test. That is something that I'm sure that your grade 10 teacher would have mentioned. So let's look at some examples for this. So the first one says, and maybe I will bring the blind up again. The first one says, state if the following are functions and why or why not. Okay, so it said up here that when given a set of ordered pairs, this means that for each x value, there's only one y value. Okay, so here I have an x of 4, and it's 7. Do I have another 4? Yes, I do, and it's 6. So here, when x is 4, it could be 7 or 6. So that tells me right away it is not a function, okay? Because when x equals 4, the y can be 7 or 6, okay? Let's look at the next one. So I have a negative 5. Do I have any other negative 5s? No. I have a 2, no more 2s. I have a 3, no more 3s. I have a negative 6, no more negative 6s. So given this set of ordered pairs, I can say that, yes, it is a function because for each x value, there is a unique y value. Okay, and the next grouping are graphs. So let's take a look at the first one. And when we look at it, and if we take actually a vertical line, and I'll just create a vertical line here, and I'm actually going to change its color so that we can actually compare it against the graph a little bit easier. I'll make it thinner too, and I'll just make it red. So when I take this vertical line and pass it, okay, here's where the graph starts. Well, automatically I can see that this line is crossing in two places. So because it's crossing in two places, it means that, no, yes, actually it's not yes, it's no. So now I have to go back there and change that. Just give me 1 second. Sorry about that. When I copied and pasted, I just copied all the one that said yes. So no, because it crosses in two places. So now let's take a look at the next example, and you can probably see even without actually taking the vertical line that it is going to cross in more than one place, right? You can see two places. So no, vertical line touches in two places. Okay, let's go over to the next one. This is actually a special graph that we're going to learn this year. It's not a parabola. If you notice, it's like a V. And this time when I take it, you can see it only crosses at one place at any one time. So yes, it passes the vertical line test. And let's clone this vertical line and go over to the last example. Okay, well, you can see that this circle is going to cross in two places. The only time it wouldn't is if it was right on the very edge here, but it crosses in two places. So no, vertical line touches in two places. So that's pretty much um, what we know about domain and range and about what is a function. So you can have some mathematical pleasure tomorrow in class.